There it goes. Okay, it's going now to Facebook. Okay, looks like we're back. Thanks, folks on YouTube, for being patient with me. Just had a couple of steps we had to reinitialize on. So welcome back, and good evening, folks on Facebook this evening. We're offering a view here of the Comet live. Round 3, I know. But Flo, I know we keep trying, but things happen. I guess we are live on YouTube now. That's great. Okay, and we are live on Facebook as well.
Okay.
So I was out this evening and tried to capture this view with my smartphone, and it didn't work out at all. I tried from about 7:45 till almost 9 o'clock, or till 9 o'clock, and nothing at all happened. So the Comet was just too it was too dim to be able to offer on the phone. So in the meantime, Paul had messaged me and said he has the Comet live in capturing it, live stacking right now. So that's what we're doing.
Try to make this a little bigger for folks to see. There we go. That's a little better view. So
what's the refreshing rate of the live image, Paul? How often are you refreshing?
This one is, I'm at 1/1788 of a second. So I'm refreshing very, very quickly.
Okay.
To do a live on this one. I'm unable to track the Comet as good as I want to. I tried doing some Comet tracking with the PhD guiding, but I've never done it before, so I was not real successful, but it doesn't matter. The bottom line with this one is we're able to see the nucleus of it, and we're able to see that very nice tail. It's a very thin, and it's a fainter than normal tail, but you're able to see it actually quite nicely, really.
Yeah, it does look nice. Now its closest approach to Earth will be on Tuesday morning, or Tuesday, I guess. I'm not sure if it's morning or not. I watched Halley's Comet 86. Yes, I'm that old. Colin, I was watching it too, but at that time I wasn't really appreciating what I was seeing. And I wish I had been as excited about it as I am today, because I would have enjoyed it much, much more. The Comet will make its closest approach to Earth on February the 1st, which will be 42 million kilometers. That's as close as it's going to get. But there are some other nice things that are coming up too. I think it's on the 11th of February, even though the Comet will be getting dimmer. The Comet will be passing within a degree of Mars. So you'll be able to get the Comet and Mars together, which would be really nice.
Oh, yeah.
And then on the 15th, it's going to pass in front of the Hyades star cluster, which is in Taurus, of course. So there's another beautiful idea for a capture, the Comet with the Hyades star cluster together. Yeah, we're capturing a view about every second right now, or even better.
It's not even a second, really. Right now I've got 63 frames, 64. It's going up pretty fast.
Yeah,
just to let people know why they're not seeing green, because it ain't easy being green.
Yep.
But no, I'm using a monochromatic camera, and I use filters to capture my data and then later put it together. But while you're capturing, everything's a grayscale. So so I don't have a matrix in my camera to give me a red, green, blue image all put together. So and I didn't want to swap it out just to have a look at the Comet. So, but in any event, it's more important to see the nucleus of it, the tail of it, and how actually it's quite nice. I'm looking at an image online right now of it. I'll switch over. Or can I do that?
Yeah.
Yeah, I'll switch over to screens.
Okay.
and show you the comet. I hit stop. Did I stop sharing? Yes.
Yep.
Now I'll share another screen and I'll hit the one that's got the comet on it. There it is there.
Shirt on and another shirt, another shirt. It was cold out
There
today. There we go. Oh, yeah.
we go. A photograph of it, taking a whole bunch of frames, putting it together and having it in color. So when I'm looking at what I'm looking at live, it's going in the opposite direction of what this photograph is. Because depending on who shot it and the orientation their camera was in, it can go in any direction really. But you can see here on this image, the green portion of it, the ionized portion, is really defined. And then it splits off the tail right here, and then you have this other glow. So what I'm seeing with my live version is I can see all of this detail. I just don't have the color separation, that's all. But you can see all of this in the live stack. So I'll stop sharing that.
So before you do stop sharing that, if you look back on the tail, you see the tail's kind of squiggly there at the far end.
Yeah.
So that's from last week. The Comet experienced a lot of solar. What am I trying to say? Not a solar flare, but it was solar wind.
Mm-hmm.
That's what's causing the comet's tail to stretch out, is the solar wind, is wind from the sun, or solar wind, charged particles that are pushing back on the tail. And it actually sliced it, split it there. The pressure, the solar wind pressure was so strong that it actually cut off part of the tail.
Oh.
So it's because our sun is so active lately as well, right? So we've got a very active sun with a close comet, and that's what can happen. So that's what's causing that little bit of bunching up there at the end of the tail in that area.
Okay. I'm going to go back to the live stack and show you exactly what's going on here. Stop that share, and then I'll start this other share again, and go back to the Comet. And I just restarted the Comet, so now you can see that we have that very definitive dot in the center. There's that tail. Again, that's going the opposite way that the photograph did. And here's that separation right here. So this whole portion of this would be that really, really ionized green or teal that you typically get. And then the rest of this would be the, I guess it would just be ice coming off of it. Would that be correct?
Yeah, sublimation. Yeah. So the green is caused by cyanogen, the molecule cyanogen, and diatomic carbon, it's called. Mm-hmm. And those substances act elaborately, I'll say, with charged particles from the sun, similar to what the aurora does. When it actually causes a magnetic reconnection in the comet, and similar to what aurora does on our planet.
So I'll just make this a little bigger so you can see it a little better. You can see more definition in that tail with each image that we stack. But it's actually quite bright. I went out and looked at it tonight. Once I found out how to find it and and how to star hop to it. It was actually quite easy, and once you find it, you can't unfind it because it's way different looking than anything else. But what I would recommend, if you're looking at it with binoculars, which you're going to have to at least, is use your averted vision. In other words, don't try to look directly at it. Just sort of look around, and your eye will automatically see that what looks like a little blob right there. And then as your eyes start to acclimate, and get used to being in the dark, you'll be able to see it better.
Let me share my screen, Paul, if you would, just for a second. I'm going to share, because a lot of people were commenting on where to see it. 1 second there. Get this.
There's somebody commented on your page actually and had a little picture of a drawing of almost looked like a cat.
Right.
And it showed exactly where it was. So when I saw that, I went right back outside and just found it immediately.
I don't know why I can't share.
If you take the end of the Big Dipper at the end of or Little Dipper at the end of the pot and almost make an equilateral triangle.
There it is.
Yeah, so there's what I was trying to describe it tonight. So yeah, some people were saying they couldn't see it. Now you got to be like, we were at I was at Millersville North School here in St. John in the parking lot, and I had a really good view north, but I had lots of lights around the building, and there were lights in the parking lot, so my view wasn't great. I could get it through the scope. I even tried an 8-inch telescope on it, and it was there, but almost had to use a vertivision to see it. And then there was no way I could capture it with the phone at all. Not like NeoEyes. I did offer NeoEyes through the phone, and it was much brighter. So here's where you want to find it. So if you do happen to go out tonight and you still have a clear sky, this may have turned a little bit. Like these are going to turn, of course, right? Everything rotates around Polaris. So, but look for the Big Dipper and take the 2 stars that are the last stars in the pot, Merak and Dubhe, they're called. Follow them straight out. The first star you're going to hit is Polaris. That's North Star. Take that North Star and follow down. There'll be 1, 2, 3, 4, 5, 6, 7 stars. If you're in a really dark spot. In St. John, I was only able to see this star and these 2 down here. So if you find these 2 at the bottom of the pot, within a binocular view, put that star in your binoculars, and within the view of binoculars, you'll be able to pick out the comet. And I did that tonight, and I was able to pick it up. So that's the best way to find it tonight. Tomorrow night, it's going to be up around this area, and then it's going to move really quickly up this way because the comet's getting closer to us. So the closer it gets, the faster it's going to be moving across the sky. And again, by February the 11th, it'll be up beside Mars. Mars is a long ways away from this part of the sky, but it'll be up by Mars, and you'll have Mars and a comet together. And then on the 15th of February, we'll have the comet and the Heidi star cluster together. So, yeah, this is the best way to find it tonight. It's probably easiest to find it tonight than it will be tomorrow night when it's up in this area or even higher with Polaris. So just take a look at, again, for Polaris, drop down, find the 2 stars that sit at that edge. Those are the brightest stars in the Little Dipper anyway, besides Polaris. And it should be a pretty easy target. Okay, you want to go back to your screen, Paul?
Okay.
Has that other tiny asteroid flown past us yet? I think it has. It wasn't what was that one? It was ZTF, ZF. It was actually like 0.1 of a lunar distance away. So that would be about 24,000 kilometers. I'm sorry, 4,000 kilometers. No, it wouldn't be. 400,000 kilometers to the sun, 0.1 would be 40,000 kilometers away. So it's not as close as this one was. This one actually showed up as 0 lunar distances, which is 0.0007. So it was much closer.
Paul, I wonder if you could just zoom out a little bit, see if we can get that star from Polaris or from Ursa Minor in there.
Okay, there's my complete field of view.
Yeah. Wonder if maybe it's probably too. Yeah, I don't think we catch that canard.
No, I'm at almost 600 millimeter focal length. So.
Okay.
Annie asks, is it still out there right now? Yes, Annie, it is. It's going to be out all night long.
Yeah,
it stretches quite a ways, doesn't it?
Yeah.
So see where Polaris is. Polaris, the North Star there. It's north, and we are tilted towards that star. So the Big and Little Dipper and a few other constellations rotate around that all night long. So they're what we call circumpolar. So this comet will be up all night tonight, right till sunrise. And again tomorrow night, and it'll stay circumpolar now for at least a week. I'm not sure exactly how long, but so yes, you can get out and see it tonight. Again, just watch where as those 2 constellations move around the sky, they move around Polaris. They're going to move over the hours here. So just follow the last 2 stars of the Big Dipper pot and straight over to Polaris, then down to the last 2 stars in the Little Dipper. But yes, you'll be able to catch it all night long.
So what you're seeing here, in case for those who aren't familiar with how the sky kind of works and how comets work, you're starting to see some elongation on the tip of the comet. And the reason you are is my system is actually locked onto the stars. Now the stars in relation to us move at a different rate than what the comet is. So because I'm locked onto the stars, my stars will stay round and pinpoint, but the comet won't, because the comet's actually moving. So I've found some software, but I haven't been able to practice with it yet to be able to actually focus and keep them locked on the comet. So if I did that, then what would happen is you would start to see the stars starting to trail like that comet's trailing right now. So I find that this is just a little bit more pleasant view because where it's not a really well bright defined comet, so long as we're seeing the tail of it and the core of it going like this, it's a little bit more of what you might see if you're looking through the binoculars.
Yeah.
Also, it gives you an indication of how fast that comet's actually moving.
Yes.
True. Yeah, well, it's moving at, so it is moving at about, now, if you folks want to share, we're going to be on here for probably 20 minutes anyway. Love to see as many people as they can see this view. So if you're on YouTube or Facebook, you get an opportunity to share, please throw it out there. And I did a quick calculation because I was talking to Vanessa Vandervalk earlier on CBC, and I was thought maybe we'd get into that conversation, but it's moving at about 40 kilometers a second right now. So 40 kilometers a second, in a year, it'll travel 1.261 billion kilometers. So it's a 50,000 year orbit. So in 25,000 years, will have traveled 31 quadrillion, 536 trillion kilometers. And I think, no, I'm sorry, it's more like 31 trillion kilometers. So that's about 3.15 light years. So that's about the width of the Oort cloud. So these comets and asteroids are out in a large ring that surrounds the solar system, and we call it the Oort cloud. And it's made up of millions of comets and asteroids, icy bodies that were left over from the formation of the solar system.
I'm going to stop sharing for a minute there. I pressed the wrong button there.
So, so these comets come from out there in the Oort cloud. They all travel at different rates of speed around our solar system. Occasionally, a couple of them will bump into each other, and then one of them might get sent off in their direction. So 50,000 year orbit, that's a big orbit. It's actually, the plane of the planets is this way, and I think I can bring up a picture of that. Let me bring up a picture of how it's set up. Just bear with me.
Yeah, it's probably in the area of the one tree that didn't lose a branch in my backyard.
Okay, so here's a great page. Paul, I'm going to share while you're doing that. I'm going to share this page for a second. So here's a page from the page called theskylive.com. And it offers a lot of information about comets or asteroids or whatever else. I go in here to find, tonight I went in here to look at where it was located, the right ascension and the declination. In other words, the coordinates in the sky where it was. It says it's in the constellation of Ursa Minor. Its observed magnitude is 5.2 right now, which is naked eye visibility from a dark sky site. Usually 6 or under is visible in the dark sky site naked eye. If I go down here, though, here's the position of it right here. So there's Little Dipper, as we showed earlier. There's the stars, and we're just within a binocular view off to the right, I'll say, of those two stars. Farther down, there's a closer view, so you'll know where you are. And if I keep going down the page, here's its closest approach to us right here, and then back up again. So this is how it's going to drift away over the next 6 months. These are astronomical units. So when it gets to its closest approach to us, it's about 40 million kilometers away. It's 160 million kilometers to the sun. So about one quarter or 0.25 of an astronomical unit. And we can see over the next number of months, it's still going to be visible, but its magnitude, its brightness will dim as it gets farther away from us. So still by July, though, it's still in our evening sky. We're going to keep going down here a little bit farther. Here's the brightness that was predicted for the comet. So they run this out from like last January, and this is what they predicted the comet's brightness would be. So you'll see that it's going to start drifting off here pretty quickly for the first few weeks anyway. But I like this one here, this final one down here, which shows me the 3D view of what's happening. So this is kind of cool. So there's its orbit. You can see it basically there. 50,000 year orbit. And there's the comet's location right now in compared to Earth. So we can see that it's dropping down in front of us, you know, in between us and Mars. So that's why it's going to move very, very quickly across our sky, with this as a backdrop, of course. So that's kind of a neat place. It's called theskylive.com, and you can go in there and just type the comet name, and then type the Sky Live on Google, and it'll bring you up to this page. And there's the right ascension declination, all the coordinates for the next little while, right up to February 3rd, and the constellation that it's going to be in. So they offer a whole lot of information here. It's really, really quite detailed. There, hopefully that'll help you find it a little bit. You're in the northeast of New Brunswick. Where do I look? Lolly, you want to look right where I showed earlier. Just I'll bring up that chart once more.
Just a sec, I'll turn this share off.
Okay.
There you go.
So here we are. Here's our chart again. So here we are with the Big Dipper. Find the Big Dipper out there. It's the bigger constellations, really Ursa Major, but we're going to call it the Big Dipper for us anyway. Look for the last two stars of the bowl. They point directly over to Polaris, the North Star. Follow that star down to a backwards handle, very faint, but it's there. And then you'll see another pot. And that pot there, you'll see two bright stars at the end of the pot within a binocular view. So put this star in your binoculars and just look over to the right, and you'll see the comet sitting there.
Can you make that picture bigger, Chris?
Not sure if I can. I don't know if I haven't figured that out yet. I don't think.
Okay, because
Try your scroll button. Just scroll.
I tried to scroll. It takes me to a different picture.
Ah,
I haven't got. Yeah, see, it takes me to that picture.
that's a good picture.
Okay, the reason I'm asking is because how I found it. If you can go right back to with your mouse down to where COCAB is.
Oh, here. Hey, no, I can bring it here. I think. Yes, I can. Here we are.
Okay,
there.
You see where your line pointing to COCAB is?
Yep.
Right there. There's another star right straight up from it.
Right.
Right there.
Right there.
When
Yes.
you see that star, then you automatically just do a 90-degree line out straight over, and that's it. So it's like an L. So you take those two stars of the Little Dipper, and then up to like the bottom one before COCAB, and look up to see COCAB, which is going to be the brightest, and then keep looking through there. You'll see that little stars, and it's in the binoculars. It's quite bright, and then automatically just start looking to your right. And that's exactly where you're going to find that thing.
It's not going to be as bright as the stars. It's going to be fuzzy, like a fuzzy ball. You might have to use a version, in other words, the side of your eyeball.
But it's a lot bigger than a star.
It is, yes, yes.
It's considerably larger. It'll almost look like you're seeing something like a floater in your eye for a second. But that's not what. If you see that, then you're there. And then once you find it, you can't unfind it.
So Irene says it's 10 now. Should it still be there? Yes, it's going to be up all night long, Irene. So this constellation and a few others orbit around Polaris, and they're what we call circumpolar. So they're up all night long. So you will be able to see that all night. I'm going to try to I'm going to stop sharing here. Paul, get you to go back to the Comet. I'm going to get Stellarium open.
Okay.
See if I can show people from there. I show you here just for a
Here's the
second.
Comet. Again, you can see that it's starting to elongate at the very core, but again, that's just because of the way that we're tracking it. But yeah, so for Irene who asked, is it up? Yes, we're looking at it live. So
I'm going to open up the program called Stellarium, and it's going to offer me a view to show you of where it is and what I mean by the constellations being circumpolar.
Let me know when you're ready, Chris. I'll stop sharing.
Second here. I want to get it set up so that it only shows one constellation at a time, which is okay. Let's try this one.
There's a little tiny galaxy right back there on the comet. I'll make it a little bit bigger so I can see it. It's kind of cool. I never noticed it before. So if we go back here, there it is right there. Little galaxy.
Yeah.
She's a little baby, but she's there.
Yeah. Okay, so I could probably do it now, Paul, if you don't mind.
Yeah, there you go.
Okay, so let me show you what I mean by circumpolar. So it's almost 10 o'clock now. I'm going to actually bring up the comet first of all, too. Oh, it's there. Okay. Move my screen around, and now I'm going to share. Share this one. Okay. So there's the comet, where it's located right now. You can see that, guys? Still there?
Yeah.
Okay. So there's a comet where it is now. Now watch when I change my time. This is 10 o'clock. So there's 11 o'clock, 12 o'clock. See, right through till the morning. It doesn't move much before morning, but you can see that all the stars are actually rotating around that one right there, Polaris. So is it up all night? Yes. And it's what we call circumpolar. So these constellations never set below the horizon. In other words, they stay above the horizon. Now, if I move it this way, more you can see the horizon. Now you'll be able to watch that star Polaris and see that it doesn't really move. So some of the constellations stay up all night long. And thankfully, because the comet's located in that position, it's going to be available all night long. Now let's move it ahead a couple of days and see where it goes. So there it moves up farther and even farther and farther. See how quickly it's moving though now? Over those next few nights, it's going to move pretty quick across our sky because it's getting closer to us. So you can get that from the program called Stellarium. It's a free program. You can download it. There's also an online version. And once you set it up like this, you can see objects that you're concerned or looking for pretty easily. Okay, we'll stop sharing that. Hopefully that's helped a little bit. I'll be up with our YouTube feed. Here we are. Oh. Got 15 screens open here. There. Will people in Toronto, Canada be able to see it? Yes, you will. Well, you will, Amanda, if you are, Toronto, Canada's pretty bright sky. If you're using a telescope, you should be able to pick it out. I had a little bit of trouble here in St. John. The light pollution here is less than it is in Toronto. So you're going to have a difficult time if you can't get away from the city lights. It's not that bright. 5.2, it's saying now between 5.2, 5.5. Anything below 6 is supposed to be visible naked eye from a dark sky site. Don't know how many stars you can see in Toronto, Amanda. Can you make out the whole shape of the Big Dipper? And can you see Polaris? I know when I was in Toronto last time, I saw, I think, 4 stars in the Big Dipper, but I couldn't see the whole thing. And that's our problem, really, is that there's so much light pollution now that it's really difficult to pick out a lot of the objects in the sky that we'd like to see. And it's getting worse, of course. Stuart says, found it really easy with the help of your map. Thanks. Oh, that's great, Stuart. I'm glad. It's not as
Can I quickly show you something?
Sure, please, yeah.
Quick share. I think this is it. Let me know if this comes up and you can see it.
Mm-hmm.
There should be a video there. You see the video?
I see a picture of a William Optics telescope.
That's the wrong video. Hold on. Where did it go? Get rid of this. I had it playing. Give me a few minutes, I'll find it again. What I wanted to show you is, as Paul showed you, whoops, his comet is getting elongated. And I actually, way back, or a little while back, did the same thing that Paul was doing, only what I did was I took individual images of the comet as it moved.
Right.
And you can see how fast it's moving across the sky and why his image that he's on would show as elongated. Let's see if I can try this again. Screen 2.
I'm watching your comments, folks. I'm going to comment on your comments here in a couple on your questions here in a couple of minutes.
All right, do you see it now?
Yes, yes.
So you see how fast that's moving across the sky. That was probably 15 minutes of images.
Yeah.
And so that you can understand why your comet, your image would be elongated, because look how fast these comets move in the night sky. That's probably, about 15 minutes worth of images.
And the closer it gets, the faster it's going too.
Yeah.
From our point of view, the quicker it's moving across the sky, right?
That just gives you an idea why, if you're trying to, like you say, Paul, if you're locked on a star and tracking it, why it's going to get elongated.
Yeah, elongated image on the thing. Yeah, it's fast.
It's moving.
Susan says she just found it. Thanks for the guidance. It is fuzzy. It is fuzzy, Susan, for sure. Found it and wasn't sure I was looking in the right object, but now I know. There you go, Bridget. The thing is, it's not one of these gargantuan comets, the big Halley's Comet, or Hayatuki, I think it was called, or what it was called, Hale-Bopp, or any of them. It's not leaving a big, beautiful evening trail. This one is a bit fuzzier, and somebody mentioned about so how do comets get their power to move so fast for so long? Well, it's all the fact that there's really nothing to slow it down in space. If it gets bumped from the Oort cloud at a certain speed, it's going to travel pretty well close to that speed for forever, really. Some other bodies are going to affect it. Of course, as it gets closer to the sun, it's going to speed up. As it drifts back out again, it's going to slow down. So the average speed, they're saying, is about 40 kilometers per second. Other bodies can affect it too. If it passes by another planet, Jupiter, like a large body like that, it can affect it. But their speed is relative basically to what happened as it was exiting the Oort cloud. In this case, constellation looks like waving cat. Yeah. In comparison to Jupiter, where do I need to look? So if you're looking at Jupiter right now, you're looking south, Jess. So turn around, put that to your back, and look north towards the Big Dipper. Evening Star Lord. Hey, Sean. Okay, let me see what else we have for comments. How far above the horizon? It's right now. It's about. If I can bring up stellarium.
It's actually about 40 degrees.
Yeah, it's quite high.
Yeah.
So 40 degrees. So if you had your fist held out to the horizon, that's about 10 degrees. So about 4 of your fists above the horizon. So it's up quite high. And the longer we wait this evening, the higher it will be.
Take your phone outside, if it has a compass on it, point it north, orient yourself north, and then look up 45 degrees and you'll find Polaris. And it's
There you go.
Susan, not too far from that.
Susan says, I just went out and looked for the comet and found it no problem, but in my binoculars, it looks like a little cotton ball. Can't see it. That's true, Susan.
Bingo.
You got it. And the reason why is because like the image that Paul is showing here with the tail is because he's stacking images one on top of the other. He's taking a picture about every second or so, and every time he takes a picture, it brings that image clearer and clearer, or brighter and brighter. But unfortunately, with our eyeballs, we can't store photons of light like that. When a photon of light leaves the comet, or if you're looking at something in an eyepiece, it's a photon of light that left, the energy of a photon of light left that article that you're looking at, if it's the moon or if it's a star, galaxy, whatever, and it traveled through space and released its energy when it hit your eyeball. So, but that's an instantaneous thing. And we can't store photons of light on our eyes. So we can't get the images that we would see, like Paul has in the background there with the nice big galaxy view. You're not going to get to see that through a telescope. This is what you're going to see for a galaxy, pretty well the same through a telescope, but you're going to see it live. The idea is that you're seeing it live, not a captured view. So our eyeballs can't store photons. They release their energy the instant they hit our eye. So there's no way for us to see a glorious tail unless it's a huge glorious tail and very bright, and like some of the other comets that were appearing many years ago now. Like we're due for a nice one. Like we're about 20 years overdue for a nice big comet.
I'm just trying to get the contrast up on this a little bit more so I can see that tail a little better, but it's hard to do because with the moon still up too, it's not a real ideal night, but it is in the opposite direction, so that helps.
Hello from Vancouver. Welcome. Why is the comet goes around the Earth instead of going straight line on its path? Well, there again, it's because of how it interacted with the comets, the other comets that are in the Oort cloud out there. And when two particles collide in space, they don't necessarily hit this way. They may hit this way, or it all depends on how it's released from the Oort cloud. The collision that it had with another object in the Oort cloud that caused it to be released from that cloud, from that big ring of comets and asteroids, and head out towards in our direction. So they're a parabolic path, and they may be horizontal. It depends on how it got released from the Oort cloud, what collision it experienced 50,000 years ago. And it may have been even longer than that. It may have, 50,000 years ago, might have been just inside the Oort cloud or just to this edge of it. So it's really hard to say, but it all depends on two bodies colliding together and what direction they happen to go from the release of the collision and the energy from the collision. Hopefully
so what keeps it in orbit? Like what keeps it in that pattern?
Well, the sun's gravity. It's the same as why the Earth is still in an orbit around the sun. It's just in a long, elongated orbit. That's all. It takes 50,000 years to orbit the sun once. But it's the sun that's causing it to orbit.
You can talk about the fabric of space-time if you want to get into that conversation.
Well, I just find that it's intriguing because how far out that it actually goes.
Yeah.
And it's still within the pole of the sun.
Yeah, it's the sun's gravity is immense.
You picture the sun's gravity as a fabric of space-time, and everything is in a funnel. And it's all in the center. The sun is the heaviest object or the largest object. So it pushes farther down on the fabric of space-time, and all the other articles are going around. You're probably taking a penny and throwing it in one of those things, and it just keeps spinning around and around before it falls. So our planet is spinning faster around, and it's okay. Orbital velocity, is that what we call it, Mike?
It's almost like catching it in a vortex, isn't it?
Yeah.
Yes.
It's the same reason why the space station stays in orbit, is because it's traveling faster than it's falling.
Right.
But I mean, the Oort cloud itself is influenced by the sun's gravitational pull. That's why it stays as a disk around way out there in our solar system, and that's why it's still part of our solar system, is because of the sun's influence, the gravity of the sun's influence.
And that's all the way up to 3 light years, so it's quite distant.
That's a long ways out. Like you say, it's incredible how powerful the sun's gravity can be.
Fabric of space. We won't get into that conversation too much, Miss Kimby, but
I mean,
I'm going
1972 was it? They were launched, and they just got outside the the sun's gravitational pull, the Voyager spacecraft.
45 years later.
So that's how long it took for them to, fly in at whatever 40,000 miles an hour to get out past the sun's gravitational influence. That's crazy.
And they still have 1,000 years before they reach the Oort cloud itself as well. So
if you look at that image now, you'll see how pinpoint that nucleus is. I'll make it even bigger. And that's going to spread because of the way that I'm tracking, but that's typically what it would look like, and that's what it is. It is in fact a pinpoint, and there's all kinds of, because of the speed and whatnot, all kinds of stuff coming off of it, including the tail. So when that starts to elongate, it's not because anything's happening to the comet. It's just how I'm taking the pictures and not being able to put them on top of each other, line them up first and then put them on top of each other. They're just kind of lining up where they happen to be falling at this point. But
Here's the confusing part as well as the tail. The tail doesn't necessarily follow behind the comet. It depends on the solar wind that's blowing on it. So that tail could actually be in front of the comet, even though
right,
it looks like it's behind.
It's all in our perspective of how it's approaching us as well, right? So
Yeah,
we may not see a tail at all, but it might be facing us, you know.
that's right.
And, would it take? Did I say it would take 1,000 years for it to reach the cloud? Well, it's the cloud is anywhere from 2,000 to 100,000 times the distance between us and the sun. So that is about 2,000 times 160 million kilometers.
I wonder if I have a.
She's out there. She's out there.
I can do a quick calculation.
You see this chart I'm showing you right here? This is a software called PhD guiding. It's what we use to stay locked onto a star. And that's why I have that green light there, because I'm locking onto a star. But there's the comet there. And there's where I started. So just from that short period tonight, and I am guiding, so I haven't moved from the star at all. That's how much distance we moved.
Have you tried to see if you could get a lock on the comet as a star?
No, well, there's a right up here. If you go to tools, there's a comet tracking system.
Yeah.
I haven't figured it out yet. You gotta train the guiding to you still do it on a star, but you put the comet in the center, and then when you hit start, it's going to come up with this little device here.
Okay.
And then you have to move it up, down, left, and right. But I haven't quite figured out how all that correlates, because you're going to spend some time on it.
Almost like a drift alignment.
Yeah, exactly. So you have to train your guiding to stay locked on the comet. Once you do that, then the comet will stay pinpoint. The stars will start to elongate.
Yeah, I was just wondering. Of course, I'm in the tree, so I can't try it, but I tried to see if I could use the comet as a star to lock on.
Yeah, if you do, you'd have to change. See what it is when you're using the
rates. Yeah.
Here, I'm using a sidereal rate.
Yeah.
So that's the speed of the stars.
Right.
If there was a comet rate in this, then that's exactly what I would do. I'd pop it on the comet and put it.
And away you go. Yeah. Yeah. Yeah.
But anyway, so that's what we're using, and but you know, either way.
Oh, you're getting a beautiful shot.
We're still able to see it. That's the main thing.
Oh yeah.
Yeah. Yeah, it's nice. It's nice to actually look at a comet, because the last one we saw was Neowise.
Neowise, yeah. But I remember.
It was gorgeous. It was unbelievable.
Seems like forever now.
Yeah, it does, doesn't it? That was 3 years ago, 2 years ago.
Yeah, at least.
Yeah.
I remember seeing that for the first time, naked eye. I was driving. I was looking for it, and it was in the northern sky. And I got to that hill just before you crest over where Sussex is on the highway, where you can see all of Sussex, and it was pointing, like it looked like it was going right for Sussex. It was unbelievable, and that's where I got my photograph from when I shot that one. So
yeah, July 2020.
Well, there you go. It's going on 3 years.
Yeah,
unbelievable. Comets are cool. I remember when I was a kid, and when I was going through space magazines, and I always, thought, what would it be like to actually be on a comet and travel with it, and just to see what it sees. And anyway, when you're a kid, that's the kind of stuff you think about. But I don't know if I've changed a whole lot since then, because I'm
Okay, so to reach the edge of the Oort cloud at 40 kilometers a second, it should take about 253 years at 40 kilometers per second.
That's not long at all.
That's just the edge. That's the inner edge, and it can stretch another. That's 2,000 times the distance between us and the sun, and it can
Wow.
as far as 100,000 times the distance between us and the sun.
That's amazing.
Take that times 50. Yes, 2,000 times 50 would be 100,000. Yeah, so times. Sorry.
It's interesting if I was to just leave this and just let it go all night, like for a few hours or even, it'd be interesting, like what Mike did with the time lapse. You would see the stars stay exactly where they are, but you would see a line
Yeah,
of which way the comet's actually tracking through the stars. Then you can look at a star chart and see exactly how it's going to track. It's kind of cool.
I got to finish this. 40 kilometers per second to reach the other edge of the Oort cloud, as far as we know that it's out there for 12,650 years.
wow.
Now,
Well,
can we see this Nova Scotia dust? And says, yes, you certainly can.
Yeah.
You just look for, again, look for the Big Dipper. Maybe I'll share that one more time, Paul.
yeah, let me just stop sharing here.
Okay. So I'll grab
Actually, you know what? I've got the my software up that's actually where I'm locked onto that.
Oh, okay.
But go ahead. Stellarium's easier because you know
I
what
got
that.
Stellarium right here. So let's I'll bring the names of Stellarium up to Maples. Yeah. Okay. So let me share that screen. Time.
Actually, no, it's right here. I can show you right where I'm locked on it. When you're done, I'll show my thing of it.
So there we are with Ursa Major, or the Big Dipper. No, this part is a Big Dipper. Of course, it's a bear. You know, we'll bring on the artwork. You can see what I mean. There you are. There's a bear. So we'll take it back off again. So here's where we're looking. This is 1018 right now, and there's where we are. We're about 30 degrees. So put the measuring tape on. Yeah, we're about 40 degrees above the horizon. So that's about 4 widths of your fist above the horizon. You're looking north, of course. Take that back off again. And if we take these last 2 stars of the Big Dipper pot, we stretch right over to here. We're going to hit that star called Polaris. That's our North Star. And let's follow that down 1, 2, 3, 4, 5, 6, 7. You might get this star and these 2 stars from a city lights, like where I am here in St. John. Go back over there to the chart. Let me do that or not. Yeah. So let's go back and try to find the comet again. There it is there. So this area right here, let's bring on the binoculars. I'm going to go there. There's a binocular view, 10 by 42 binoculars. There's the comet. There's that other star. So you can see the 2 of them fit inside the field of view of just binoculars.
So binocular tracking in the night by Bino Bud is coming.
Distance, that distance or not, without losing the comet position. Let's try it. Yeah, so 3 degrees, 3.5 degrees, and field of view of most binoculars are 7 degrees. So you can get the 2 of those objects together.
That'll be 6 full moons.
6 full moons. Okay, hopefully that helps anybody who's still out there trying to find it tonight. And again, tomorrow night, it's going to be there. And the next night, it's going to be there. So we get 2 clear nights, tonight and tomorrow night. So I would say tomorrow night, you're going to be looking in this part of the sky. Winston, I was already outside, and when I saw Paul had it in the observatory, I zoomed back home. He says it's not fair to be able to be doing that from your home.
I'm just going to show you. I'll share on my screen just for a sec and show you. Did I share that? There we go. Can you see my screen?
Yes.
So this is the stuff that Mike and I use. This is a different planetarium software. But anyway, when you look at this, a second, I'll get my bearings here. There we go. So if you're standing outside, like Chris was saying, here's north. So the sun comes up in the east, sets in the west. So if you know where your sun comes up in relation to where you are, that will be the east. And of course, it's going to set in the west. So long as you are facing so that the sun is on your right side when it comes up, then you will be facing north. If you're facing on your left side with the sun that your sun's coming up, you're facing south. So long as the sun is coming up on your right arm side, you are facing north. So so this little target thing you're seeing right here, this is what I'm using to lock on to, or to get to that comet. So like we were talking a little bit earlier, if you take the Little Dipper, and of course the North Star is right there, just like Chris said, and you come all the way down, there's a star right here, and I think Mike said it's like an equilateral triangle. And so there's a star here, which is the very end of the Big Dipper. And this one, I don't know if it has a name on it. It usually comes up here, but it doesn't. Yeah, I'm not sure which one that is, but in any event, it's a very bright star.
That's Cahab.
Yeah, Cocob.
Okay, cool, yeah.
Cahab.
No, that's the bottom one on the that's the top one of the pot right there.
Yeah, that one right there.
So if you look right up next to it, you're going to see a star that's very quite bright. That's the one that was in the view of when Chris said he was looking at a pair of binoculars. 12, what are they, 15 by 50 or?
8 by 42s, yeah.
Okay, so you'll see that star, that bright one that you saw beside the comet. That's the star that he saw. So anyway, so that's where it is, and that's where my telescope was pointed, right there. So if I go back to here, you can see how just in that short period of time, how much traveled.
She's moving.
She's moving. She's clipping right along.
So it's about 1 kilometer in diameter, the nucleus. Again, it's green because of something called diatomic carbon and cyanogen, which are the chemical makeup of the comet. And it interacts well with the solar wind. Not only does it create this long tail, but it also causes a chemical reaction, I guess, with the comet itself. It's what they call magnetic reconnection, basically the same as what causes charged particles to excite our atmosphere when we have the aurora borealis. Traveling at about 40 kilometers per second, the tail can stretch out into millions of miles or millions of kilometers, depending on how big the comet is and how much sublimation is happening. And of course, the closer it gets to the sun, the more active it becomes. Again, the solar pressure, I'll call it, the solar wind pushing out from the sun can cause the tail to be a squiggly line or cut off, and I actually did cut off part of the tail last week. They showed images of it before and after, and it showed just basically a cut right between it. So it all depends on the size of the comet, and, what its orbit is, how close it comes to other worlds out there. You know, gravity from other worlds can pull on it, like it did with which one am I trying to think of? The one that crashed into Jupiter in pieces. Oh, the Levy comet, Levy.
Comet Levy 9.
9 because it was 9 pieces, right? So yeah, it's it can actually do that as well. I mean, other bodies are going to affect anything that passes through the solar system. Gravity is an invisible force that acts on us all.
That's amazing, just watching that comet move. You know how sometimes you see people take a whole bunch of images of a moonrise. Well, Matthew actually did that. And it looked amazing. So that's what this is. So what I'm going to do, like even when we're done, I'm going to let that run for a few hours, and just to get an idea of how far.
Like you say, you get star trails, now you get comet trails.
Yeah, exactly. It just because again, where the stars are so locked on, like you can see exactly the pattern of the comet. It's really interesting.
Paul Crowder says here, no clear lights forecast for the UK. Sadly, sorry about that, Paul, but I'm glad you could join us here. At least that's the one good thing about technology these days, and the fact that we have the internet and we can reach out to other parts of the world who don't have like we have cloudy skies a lot. And I've been able to tune into other people offering a live view. So we're glad that we can do that here.
Let's go to 100% in there and get a little bit.
Really? Wow.
There.
Yeah. Wow. Now
There's
Annie says,
distance, eh?
Annie says, I finally found it with the binoculars. Easy. I will find a way to take a picture of it with my camera. So there you go, Paul. So Paul or Mikey, the one, what would you suggest for someone using a DSLR, for instance, and taking a picture of this?
I've used it with a telescope. As a matter of fact, I got one, Comet Lovejoy, back in 2015, I think it was. And I just put the telescope or camera in a telescope and pointed it up there with just like, I don't know, seconds. And it wasn't traveling quite the speed this one is, or maybe it was, but not the angle. So our interpretation of how fast it was going was a little bit better, so it didn't trail quite as fast as this one.
Right.
But you can put it in there, just point it at it. You probably don't even have to track. If you can, that would be better. But if you don't, you should still get a relatively good image. You'll have to play with exposure with that, because again, depending on where you're shooting from. Right now, we got a little bit of a moon up there, and if you're in a bright sky, it probably won't be that impressive.
Yeah.
So dark sky would be, certainly a big plus for you.
This might help as well. I could show you here in a second. But
Yep.
Robert Cadet took a picture using a Canon 7Ti
Yeah,
with his nifty 50 lens,
yeah.
which is f1.8 with an ISO of 1600.
There
And he
you go.
took a 12-second exposure with no stacking. And I'll show you the picture
I'll
here.
stop sharing. You go ahead, Mike.
Just make sure no other information shows up here. And you should see it there. That's a single 12-second photo.
There you go.
So that's with a 50 millimeter lens at 1600 ISO in 12 seconds.
There, so. you
So
can't-
again, and keep in mind, if you are using the more focal length that you use on your lens, then the more you're going to notice how that comet is moving. Because the larger, more magnification that you have, then you're going to start to, even same as if you zoomed in on the picture even,
Yeah.
you'll start to see that it's, it'll start to pull apart a bit. Same as
Yeah.
what we're seeing here with mine.
Yeah.
But I mean, that's what's possible with just a DSLR on a tripod, non-tracking.
Yeah, absolutely.
And you might be able to get the same with the smartphone, like you'll get close, because a lot of the phones today are really good, like.
Sensitive, yeah.
Yeah, you can do a lot with a camera and a tripod.
What's that rule of thumb for exposure? 500 rule or 600 rule or something?
500, yeah.
500?
Yeah, the 500 rule. Just divide your focal length. I can't remember the rule.
Yeah, I can't remember it either.
I don't use the rule. I just know that typically with a 50 millimeter lens, I've got about between 18 and 20 or 50 mil. Yeah, probably about 18 seconds, between 12 and 18 seconds, and then I'll take a picture for that long.
Yeah.
And then I'll pixel peep. I'll zoom right in and see if my stars are trailing. If
Yeah.
they are, then I'll shorten the exposure.
There's a little bit, right?
Yeah, until you get it so that your stars are nice and round. But on a 50 millimeter lens, somewhere's right around there.
Yes.
Yeah. I think I was getting 23 seconds with a 24 millimeter lens.
There you go, and that's twice as wide as a
give or
50.
take, so.
Yeah.
Winston is asking, you actually mentioned, what does better tracking, an astral program or mount tracking?
Well, they work in conjunction with each other, actually.
Yeah.
Because your mount's going to do what it's going to do. All software is going to do is try to correct it if it's not doing what it should be doing. But it's not going to make it. If you got a mount that's not tracking right, first of all, step it back a bit more. You got to make sure your polar align as accurately as possible. Once you get that, then you're tracking properly. Then you can actually track quite a long ways. If you're only shooting 30 seconds or less, and you're not using a lot of magnification, you may not even need to guide.
Yeah.
Bring up your image again, Paul, maybe?
Yeah. Oh my gosh, they're never growing. Let me just show you.
Tell Paul the ED100 is a wicked telescope for moon, and that I love it. There you go, Paul.
Oh, awesome.
Has that ever traveled across the sky?
Yeah.
Look at that, eh?
That's fast.
It's unbelievable. Looks like a lightsaber in the sky.
Well, what, it was just a week ago, it was down by the handle of the Big Dipper, right? Now it's up on.
Yeah. Can you imagine if you're able to, and what a project that would have been to actually, whenever we could start to actually photograph it and keep photographing it until it's to get that one big long trail. That would be
Oh
super.
man, that'd be awesome.
Yeah. But this is neat. Look at this. This will give us a bit of it. I'll say at the end of this later tonight. I'll just save the photo and then.
Like I said, I went the other way and took those a bunch of individual images and put them into a video just to see it move across the sky and how fast it was traveling. And
Yeah.
that's crazy. Like you don't realize they're moving that quickly.
Yeah, absolutely. It's fun looking at this stuff.
I tried to find out what that comet or that galaxy was, Paul, and I can't find it. And
Oh, really?
it's not anywhere on my software.
Yeah.
It's there, obviously, but I just don't know which one it is.
There it is. There.
Yeah,
Right there.
jumps right out at you in the photograph, no question.
Yeah.
So let me, I can share another screen here, Paul, if I could for a sec.
Yeah. Yeah. Yeah.
And there's a ton of them up and around there, isn't there?
There is. There's a whack of them.
Yeah.
Here's that disconnection I talked about, the comet. So this was on spaceweather.com, and a gentleman had filmed this. So watch this.
Oh, there it is. Or is that Andromeda?
Coming up here. So you see how it disconnected here?
Oh, yeah.
That's
Looks
that's,
like it's pulsating.
yeah.
Is that the James Webb?
No, that's it's a gentleman that did this. It was a video he captured over. He had a bunch of frames, right?
Okay.
That's
I'll
cool.
get back to the information in a second.
I wonder if he used the camera lens. Because I'm looking at the diffraction spikes on the stars, and it's almost like what you see on a camera lens.
Well, that tail's long. Look at that.
Wow.
Yeah.
He's got better skies than we got.
He's in Portugal.
Wow.
That's fantastic.
Let me get back out of the screen. And it says, disconnect. Last week, a CME hit Comet ZTF, a CME. So it was a coronal mass ejection. So these big clouds, billions of tons of particles, charged particles that are leaving the sun, usually from a solar flare. When it broke the comet's tail, it says, yes, it's a real thing. Astronomers call it a disconnection event. Astrophotographer Miguel Claro made a 4K video of the event from the dark sky Alcava Observatory in Portugal. The time-lapse sequence comprised 3.5 hours of images, shows a piece of the plasma tail being uprooted from the comet's head and then carried away by the solar wind. This long-distance traveler, not seen in 50,000 years, was moving fast against the background starry sky alongside a few rapid greenish meteors. So CMEs hitting comets can cause magnetic reconnection in their tails, sometimes ripping them off entirely. So NASA's spacecraft watched this happen to Comet Encke back in April 2007. Another movie, so that might show that. Here's there.
Right off.
Yeah, blew it right, sheared it right off.
So pretty amazing stuff.
To see it go by like that too.
Yeah.
Wow, look at that. Just cut it right off.
And takes it with it. That's amazing.
Right there.
Ooh.
Oh.
Wow.
Did it create another one? It must have. I think it's hard to.
It's interesting stuff.
Yeah, very cool.
Okay. Another view, Paul. Might go.
All right, take another peek there and see how we're doing. Oh no, we're good. I was looking at the
Oh, at the galaxy.
yeah. Oh, where'd it go? Boy, that was fast.
There we go. Maybe.
Yeah.
There she's going. She's it's almost the width of M40, Mike.
Yes, there you go. Look, it's gone between two stars.
Ann Davis says, how long have you all been doing this? Well, it's been a while.
Yeah.
Oh,
you guys have been at it way longer than me.
Yeah, I think I started back in 2004, 2005, I think, when I started to get a little bit serious about it. The page the Astronomy by the Bay page comes up to 7 years here on February 1st.
Yeah, it's hard to believe, eh?
There you go.
That's
You know,
right.
that came when we were at we had our first workshop. All of that came from right around that time.
That time period.
Yeah.
7 years. Wow.
Yeah. Yeah.
Where's the time go?
Yeah.
As far as the rest of it, Ann, Mike's been in it longer than I have.
We're all still looking at the same dots.
The three of us have been on the show now for about 160 episodes, so about 3 years of the show, just on the Sunday night part of it. But it's just all been fascinating to all of us. Like there's just so much up there to enjoy. We're just looking at one little thing tonight.
Yeah.
So much else out there that, there's the Orion Nebula tonight. Betelgeuse is, going to go.
Oh my gosh. Yeah. I mean,
The mornings or the evening sky are all lined up right now. There's just the solar eclipse coming up next year, the total solar eclipse over the province.
To me, the big thing about these comets is most of them are once in a lifetime events. You'll only see this once in our lifetime, right?
Yeah.
Neo-wise, we'll only see it once in our lifetime.
Well, yeah, unless you live to be 50,000 years old.
Yeah, exactly.
You might get
You might get a chance to see Halley's Comet twice, but
No, Halley's Comet is a 75-year orbit. Yeah. So they say, though, if you're born on Halley's Comet, you'll die on Halley's Comet. How's that?
Yeah, there you go. There's one that you'll see twice.
Yeah. Well, you might not you might not see it the second time if you're born on it and die on it.
So there's two types of comets. There's periodic.
Yeah.
And then there's the ones that basically don't make it sometimes.
Yeah. They burn up on the backside.
Sporadic, is that what they're called?
sun grazing comets. So yeah, there are many of them. What's picking them up a lot is the SDO, the Solar Dynamics Observatory, or the telescopes that are looking directly at the sun all the time. So we do have
Short period and long period comets are called are the two distinctions.
Okay.
Or you're not talking about the sun grazing ones that come around the sun and get drawn into the sun.
Well, short period has an orbit of less than 200 years, and then long periods can go thousands of years.
Yeah. I was kind of referring to the sun grazing ones, I guess.
There's periodic, yeah,
Yeah, periodic and
and
non-periodic.
non-periodic, I guess.
So the non-periodic, I guess some call them sporadic. They just kind of appear and you don't see them again.
Right.
And periodic are the ones that are in the rotation that we're going to see them within their period of rotation, however long that is. In this case of this one, 50,000 years, I guess. It's interesting. They're really, really, really interesting.
Yeah, here's a sun grazing one. I can show you that quickly.
Yeah, let me just stop sharing here. There you go.
So we can see right here, back a bit. Watch the comet here come in from the bottom right.
Oh, I see it there. Yeah.
Yep. So there are a large number of those, and they happen quite often.
Well, if you go to Stellarium and just put in the turn on the comet section of it, there's all kinds of them.
Yeah. There is. Heavens Above has about 20 of them listed right now on their site, and it's just the brightest 20, right?
Yeah.
I mean, they do go down to magnitude 18 or so, which you really need like an observatory to see them. At all, but 11-inch telescope or 12-inch will pick up something down around magnitude 16.
Well, that big scope that we had, the 16-inch, that I can't remember the gentleman's name, but there was two of them, and that's all they did was look for comets.
Yeah.
And they found comets. There was so many. I had no idea. I thought, when we get excited about a comet like this one, that's it. That's what we see. But there's all kinds of them.
So the name of the comet, this one is called it's C2022 E3 ZTF. So that all means something too. A little bit of notes here on it. I know Lisa's lookup. Lisa has put up the notes about it yesterday. So to like why we don't call it just a name, as we used to do, but now they're, so that if it starts with a C, it's a comet on a path that's higher than the sun's escape velocity. The second part is the year of discovery. So in this case, it's C 2022. So 2022 was discovered.
Mhm.
The letter after that, E3. So the E corresponds to the month of discovery in half months. So January is AB, February is CD, March is EF. This is E. So it's the first half of March that was discovered.
Mhm.
Then the number three means it's the third comet that was discovered in that part of March.
Oh, okay.
And then the ZTF at the end of it is the Zwicky Transient Facility, which is an observatory that it's automated and it scans the sky, in big sections of the sky. So, I mean, they pick up a whole lot more. Amateur astronomers can pick them out as well. And if they do pick them out, then they do get named after the amateur astronomer. But in most cases now, they have the ZTF or they have some other designation behind it. Neowise, I think, was also an observatory. Pan-STARRS is another one.
Yeah.
They're observatories that are scanning the skies constantly, and they're going to pick up these comets when they're really, really faint, way out in the solar system. And they'll pick them up long before amateur astronomers can pick them out. So
Yeah.
On this, on the Soho site, it's actually a nice shot of two comets grazing the sun.
Let me just check on these.
Pop up here.
Oh, I'm not sharing anyway.
Oh, hang on. Okay.
1, 2.
One.
Watch again. There's a coronal mass ejection.
Hmm.
Down the bottom right, 1, 2.
Oh, wow.
Yeah, there you go.
And then a coronal mass ejection. No, they did not hit the sun, causing the coronal mass ejection.
Did they make it?
But the timing is pretty cool.
I wonder if they made it around.
It didn't say on the Soho site. It just said the video of two comets entering the sun.
Well, that in itself was very cool.
Very seldom do they ever make it around the other side when they get in that close.
Wow.
That is neat to see.
Yeah, absolutely.
As in that case, it just so happened after they went around the backside, the coronal mass ejection come out. And there's some out there. So, oh, it crashed into the sun. No, it did not.
Very cool. Yeah, it's amazing. This comet, like I say, I don't know how long. What time is it now? 10:45.
Yeah.
We've been on it for a little bit, and it's moved a lot because I've stopped and restarted it quite a few times.
Yeah.
But now I'm just going to leave it go. I might even just let it go until 3 or 4 in the morning, and if I can remember to save it. Because if I sleep through, and it's just going to be up all night.
It is.
Oh, yes. Yeah.
So,
Up till the sun comes up.
Yeah, and I'm tracking that part of the sky, so it might go into it'll probably go into a meridian flip sometime or other. But in any event.
So February 1st, Tuesday is its closest approach to us, 40 million kilometers away, roughly 42 million. We have cloudy skies predicted for next week, for most of the week. I know tonight and tomorrow night, I think are clear skies for us locally.
Tonight is. Tomorrow night we have from about 7 to 11. And that's it.
Oh, is that right? Okay. And
Is
then
the weather coming?
Yeah. And tonight it starts to die off around 5 o'clock in the morning.
Yeah.
Okay.
So we're washed out tomorrow night or Sunday for sure. Maybe Monday as well. Sunday night, guys, our talk this week on the Sunday Night Astronomy Show is going to be on cleaning.
Comets?
Cleaning comets. Yeah.
Cleaning comets, yeah.
Cleaning
Just sort of squeegee there and clean them off.
Robert Luke is actually not cleaning eyepieces, cleaning camera lenses, cleaning equipment so that we can see these things and we'll know that they are actually not a fuzzball.
Yeah, that's right. But it was a thrill to see that tonight anyway.
One more look, Paul, before we go, maybe.
Yeah. All right. Let me just share the screen one more time. There you go. And I'll make that larger so you can see how far it's actually gone again.
So that short time.
And we'll go to 100%. And we'll get down there. As you can see that the stars are still nice and round.
Yeah.
So they're not moving. But that comet sure is.
That's sure moving up.
Oh, she's traveling.
Wow, look at that, eh? Look how far it's gone. It's pretty much the length of those two stars now, those two larger stars.
Yeah, M40 fits right in there.
It does, doesn't it? Here's your measuring stick for M40. It's
So
it's
thanks.
and look how straight a line it is, eh?
Yeah,
It's moving along. It's amazing to see that, because like you're saying, when you look at it with the tail and everything else, you figure it's coming the same way, and the tail, you know, but the tail has got absolutely nothing to do with how it's traveling, which I didn't really know until we saw those videos tonight. That's pretty.
Kilometers a second. That's what 40 kilometers a second looks like, I guess. So,
and
Yeah.
then you know, it's quite bright compared to some of those background stars. Like it's the nucleus is quite bright.
Oh, it is. It is. It'd be interesting. Well, they're measuring magnitudes with it all the time, right?
Yeah,
yeah,
Which it was, Chris, tonight? It was magnitude
5.2.
7?
5.2.
Oh, 5.2.
Yeah.
So that is naked eye.
from
Yeah.
a dark side. Yeah,
Yeah.
not from here in St. John, I could tell you.
I'm going to go out tonight again and have a look. I'll give myself about 15, 20 minutes
Yeah.
and see if I can see it naked eye, because
That's the thing too. I mean, if you're looking for naked eye, let your eyes dark adapt first,
yeah.
and make sure that there's no light around you, so your pupils can dilate a little bit, and then take a look for the
Well,
comet.
you know what was interesting when I found it in the binoculars for the first few minutes, I kept losing it. That's why I had to use averted vision, because my eyes weren't adapted.
Right.
So, but as your eyes get adapted, then you'll be able to hold that light better, right?
Well, that would be the blinking commentary.
We have all kinds of stuff going on tonight.
Let me, one last comment. Kevin Clover's asking a question for Paul. Does your camera have issues with getting hot when you capture images for a long time?
Not this one, no. If you look down the side, let me just see if I get this go. Open this up. If you look down the side where it says camera controls, or no, down where it says thermal controls. Right now, I have a cooler. I don't know if yeah, it says it's on. So my camera is actually staying at an ambient, or at temperature, which I think it was supposed to be -15. And I don't know if I got it set or not. -6 right there is what it says, but I don't know if I turn it off and I turn it back on, what will happen. Nothing much really. Oh, there we go. So there, it was set at 0 degrees. So that means it stays at 0 degrees no matter how long I've got that thing on. It doesn't heat up like a DSLR, where a DSLR, depending on the temperature that you are, if you're midsummer, it's going to be a lot noisier than you are if it's in the cold winter, because the cold winter will keep the sensor cooler. And yes, if the longer you have a camera sensor on or gathering information, it will heat up. But when they design these astronomy cameras, they're designed with those tech coolers that are built in, so you can control the temperature on them.
Yeah, they're called a Peltier cooler.
Right.
They work really well.
Oh my gosh, yeah. I mean, keep it icy cold no matter what temperature you're in. Yeah.
Okay, I think we're going to call that a night. I want to thank everybody for joining on with us. I'm happy that we could bring you something at least. A little early, it wasn't looking really good, but then Paul sent me that savior comment saying I got it live.
There you go.
I'm happy to come back and see you. So that's it for the night. We hope you'll come back and join us again on Sunday night for our Sunday night astronomy show, of course, at 8 p.m. Atlantic time on Sunday. And our program this week is going to be talking about cleaning eyepieces and cleaning your gear, getting it ready for the season. I mean, you have some cloudy nights, so you can have time to get out and clean your stuff.
Yeah, I'm also going to leave this go for a few more hours, and then whatever I capture, we'll show that Sunday night, see how far we got with it.
That'd be cool.
So, so this is, I would say we've been running on this one for at least an hour, right? So, so we're going to say we're coming up to 11. So we're going to say 10 o'clock, and then when I stop it, then we'll look at the time that elapsed, and we can see how long that thing traveled.
Awesome.
Yeah.
Okay. Sure.
Okay.
That's cool.
Thanks, Paul. Appreciate that. Okay, so we're going to sign off, guys. Thanks very much, everybody, for joining on, and we hope to see you on